20-second timeout. Okay, so these products here, we're going to use these properties here, we're going to use them, but you do not need to memorize them like you did yesterday. So yesterday, those identity properties, the inverse properties, the other ones, you got to know those for the test. But these, you don't need to know the names. I'm just going to show you how to work with them. Okay, so you don't need to memorize any names here. But these are the two we're going to use. So let's take a look at example 2, number 1. The opposite of the square root of 50. So when you did this, all right, before you would approximate it and say it's approximately negative 7.1. All right, but we're not doing that anymore. Now I want you to ask yourself, what are some factors of 50? What are two numbers that multiply to give you 50? 5 and 10, awesome. Any others? 25 and 2. Any others? Very good, 50 and 1. I'm pretty sure those are all of the factors. And now when you look at these, what I'm going to tell you is 50 and 1, so anytime you do the factors that include the number 1, that's not going to help you simplify. So from now on, you don't need to write those. All right? You can write them if you want, but you're never going to choose them to help simplify. So we're in between these two. All right? The way to determine which one you want to pick is to find one that has a perfect square in it. So which one of these pairs has a perfect square in it? 25 and 2. Okay? So I'm going to use 25 and 2 to split 50 into two different radicals. So although I didn't say what we just did, we just used a property called the product property. But do you need to know that? No, I mean, you don't need to know the name of it, but do you need to know how to do it? Yes. So you can see the property allows us to take one radical and make two of them, as long as these numbers still multiply to give you the original radicand. All right, everybody good with that? Now, the whole point of doing this is because 25 is a perfect square. And what is the square root of 25? 5. Now, the reason I don't touch the square root of 2 is because if you ask yourself factors of 2, what are factors of 2? 1 and 2. And I told you earlier, anytime the factors include the number 1, is that going to be helpful? No. So the square root of 2 is already simplified as far as you can go. So that's why it just comes down. Everybody good on why the 5's here? All right, and then you finish the problem by putting the negative sign. Gotcha, Dave. Questions on the first one? That was how to simplify a square root. Now, here's what's crazy, all right? We said the approximation for this would be about, let's see, 49 on one side, 64 on the other, probably like 7.1 approximately. In the calculator, if I typed in negative 5 times the square root of 2, and you looked at this number, they should be basically the same. All right? Okay, let's look at number 2. Number 2, the square root of 48. Who's got some factors of 48? 24 and 2, excellent. 6 times 8, excellent, thank you. 12 times 4, Melanie's crushing it. Got any more? Awesome. Any more? Any other factors of 48? Well, we all know 48 and 1, but I'm not writing that. There's one more pair that we can use. 9 times 9 is 81. I'm thinking two numbers that give me 48. Yes, Zachary, well done. You saved it to the very end, but you got it, man. Nice work. Yes, Katya's here. 16 and 3, well done. So, I have 4 different options to choose from. What do I look for first? What do I look for first? What am I hunting for? I'm hunting for a perfect square. 16 is a perfect square, so I'm going to have that one as possibly going to use it. What is another perfect square that's up here? No, 12 is not perfect. 24 is not perfect. 8 is not perfect. It's 4. Please stop just saying the numbers. It's 4, right? Because 2 squared is 4. That's how you have to ask yourself if it's perfect. Can you take one number and multiply by itself and get that number? Then it's perfect. So 24 and 2 and 6 and 8, sorry guys, those have no perfect squares. Don't care. So now the question is, which one would I choose? Either one. But there's a most efficient one to choose. You know me, I'm all about efficiency. Which one would I choose to be most efficient, to do this problem in the least amount of time? It is 16. Because you're looking for the largest perfect square. So if you're doing a problem like this, and you come across 2 or even 3 options that have a perfect square in it, you're looking for the largest perfect square. Here's why. When I do this problem, 16, what's the square root of 16? 4, you're done. All right? But if I were to use 12 and 4, what's the square root of 4? 2. But 12, what are some factors of 12? 6 and 2, 4 and 3. And there's another perfect square. That 4, you'd have to do multiple steps to simplify. All right? I'm not saying you'd be wrong, but it would just take you longer. You want to find the most efficient path. That's going to separate you at your jobs, whether it's a creaser rate job or in the future. All right? Can you find the most efficient way to get something done? All right, so let's write it down. The square root of 16 times the square root of 3. And you told me the square root of 16 is 4. So we are finished. 4 times the square root of 3 is the simplified answer. Questions? All right, let's keep it going. Awesome. All right, now, oh man, whoo! I see a fraction, and I see 2 radicals. All right, don't freak out yet though. Look at the numerator. Look at the numerator. What's in the numerator? A perfect square. So what is the square root of 25? It's 5. So right away, I've already helped myself out by saying 5 over the square root of 3. Now, I want to be very clear. This is the answer. It's the answer. I know you're thinking it's not. I mean, it isn't, but it is. Isn't that weird? It's the answer. But the reason we can't leave it like this is because there's a radical in the denominator. So anytime you're working with any numbers in this class or next year's class or even college, and you've got an expression here with a radical in the denominator, you must do something about it. We're going to learn this process, which is called rationalizing the denominator. Here's why it's called that. What kind of number is the square root of 3? What kind of number, if I had to ask you to classify the square root of 3, what kind of number is it? It's irrational. So we call it rationalizing the denominator because we're going to take this irrational number and make it rational. Here's how you do it. I'm going to use a different color because I'm fancy. Times the square root of 3 over the square root of 3. Now, I want to be very clear. I didn't just do that magically. What is the denominator? The square root of 3. So I'm going to multiply the numerator and the denominator by that denominator. All right. Now, it's kind of crazy, but this in purple is actually just the number 1. And we learned from yesterday, if you multiply by 1, according to the identity property of multiplication, are you changing the value? No. So it's going to look different like you guys do on the weekends. You're not in your uniform. All right. But it's still going to be the same value. Jennifer! Excellent. Welcome. I mean, that was pretty magical, guys, but no one gave me any credit for that. That's okay. All right. Tough crowd. All right. So let's do the denominator first. The denominator is going to have the square root of 3 times the square root of 3. Now, we've been going the other way on the first couple of problems where you take one number and make it into 2 based on the factors, right? Remember the square root of 50? We broke that down into 25 and 2. But now I've got 2. Let's make it 1. So using that property, I can multiply 3 times 3. What is 3 times 3? 9, and make it 1 square root. And you should see that 9 is a perfect square. What is the square root of 9? It's 3. Guys, this is going to happen every single time. I want your brain to see this pattern. 3 and 3. But what's gone? The radical. The square root is gone. Okay? You absolutely could. You know, when you do it, if you're ready for that, great. All right? When I do it, I skip that step because I know mentally I just do it and write the answer. But I don't think we're there. If you are, feel free to skip it. But if you get it wrong, Isabella, I'm going to say, please do the step. Sound good? Excellent. Look at the numerator. The 5 times the square root of 3. Does the 5 have a radical? Does the 5 have a radical? No. So you just bring them over and smush them together. 5 times the square root of 3. That's it. Now again, I want to make sure you understand that both of these things are the same thing. 5 over the square root of 3 and 5 times the square root of 3 over 3 are the same thing. But one is simplified. All right? This one is simplified. That one is not. Okay? Questions? This will be the most missed question on the test in a couple of weeks. The most missed question. Ashley, yes? It can't have the radical. You're right. So that's why if you look at my answer, it doesn't have the radical. The numerator can. Very good, Ashley. Her brain sees that it's all good in the numerator. All good up there. All right, but not good in the bottom. Okay? Good thought. Excellent. Question? No? Okay. Let's keep going. All right, let's do the next one. 4 times the square root of 3 plus 3 times the square root of 3. Anybody remember what to do here? Because you have done this before. Who remembers what to do here? You have done this before. Okay, why? What? It's 7. How'd you get 7? What do you add? Very good. You add the outside numbers. What allows you to do that? Who remembers? It's not necessarily like terms. Kind of, Isabella. Yeah. But there's a certain thing about the radicands. What do you notice about the radicands? They're the same number. So if you have the same number in the radicand, you can add the numbers on the outside. So it's 7 what? Times the square root of 3. Don't forget to bring that square root of 3 with it. If you don't, it'll be wrong. It's not just 7. Okay? Is everybody good with number 1? Now look at number 2. Look at number 2. Number 2, we go to subtraction, but now we don't have the same radicand. We have 5 square root of 3 minus the square root of 12. Let's look at that 3 that's in the radical. What are factors of 3? 3 and 1. And what I tell you about that 1 is not going to be helpful. You can't use it. So the 5 square root of 3 is good. You just write it again. That's as simple as it can be. But what about 12? What are factors of 12? 4 and 3, 6 and 2, and then 12 and 1. We're not going to use that. And when you look at those two options, which one has a perfect square in it? 4 and 3, right? If you think of 6, there's no number that's going to multiply. That's a whole number that gives you 6. Like 2 squared is 4, 3 squared is 9. All right, so we're not going to use those. So I'm going to write the square root of 4 times the square root of 3. What is the square root of 4? 2. Bring down 5 square roots of 3. And now it looks like the first one. They have the same radicands. All right, so I know my answer is going to have the square root of 3 in it. What's going to be the number in front of it? 3. Now, I get every year asked this question. It's just a coincidence that these numbers are the same. That's just a coincidence. It's all good. All right? A lot of students are like, oh, will that always be the case? No, right? No. Just a coincidence. All right. Now, one thing I don't know if your brain saw. Maybe it did. I want to show you this. Okay? Do you remember when we were deciding which one to use? We were like trying to figure out which one to use. What was sitting over here with that 5? The square root of 3. And when I was choosing, I was looking for the perfect square. And what was the other one with the perfect square? That 3. So sometimes students will say, okay, if I'm in trouble figuring out which one, try to look at the other term. Maybe that radicand will help me. I think you'll see it on this one. Let's do the next one. 80 minus, the square root of 80 minus 5 times the square root of 5. So let's look at the one on the right. 5 times the square root of 5. Can you think of factors of 5? 5 and 1. So again, this one is as good as you're going to get. What about the 80, though? What about 80? What are factors of 80? 10 times 8? 5 times 16. 5 times 14 is 60. 20 times 4. Any others you can think of? We missing one? I think we're missing a couple. There you go, Aaron. And I think we only have one more, 80 times 1, which I don't care about. All right? So, which ones am I going to cross out because they don't have perfect squares? 40 times 2, 10 times 8. This one has a perfect square, 4, and this one does too. So if you're like, okay, I don't remember what Mr. Vendrick said about pick the one with the largest perfect square. What do I need to be my radicand? 5. All right, and you'll notice 16 is the largest perfect square. So that's the one I'm using, 16 and 5. All right, what's the square root of 16? 4. Was there a question, Katya? Sorry. Always. Now, let me say, okay, always if you see that this one can't be simplified either, right? Because there might be a question like, what if I said, what's the square root of 80 minus the square root of 12? Then you got to simplify, where is that? There it is. You got to simplify both. All right, so it works if you've already got one already simplified or you've simplified one already. All right, you're trying to get the same radicand. All right, so what's going to be the answer once I subtract 4 minus 5? Negative square root of 5. Now I get students that write negative 1 times the square root of 5, which I'll accept. All right, but if you want to be one of the cool kids, you don't put that 1, so it's negative square root of 5. Okay? Mathematicians won't write that 1. Kind of like with the square root, you're not going to put the index of 2, and like you're not going to write 1x. All right, we don't write that. Okay, any questions? I know that was a lot. Any questions? Okay, let's look at what you're going to do. It says complete 8 of 10. I'm actually going to change that. I only want you to do 9 and 10 right now. Let's do one more. I want you to do 5, 9, and 10. That's all I want you to do. 5, 9, and 10. That's all I want you to do. And then I'll stop you in about 7 minutes for the exit ticket. Go!